So component number 2 is going to be the limit as x approaches positive infinity of some random given function, which is f of x. This theorem says sometimes if infinity it's difficult for you to find an answer, then we can use x approaches 0 from the right of f of 1 over x. Okay. Now, component number 3 is related to that if it's negative infinity of f of x. And again, if negative or positive infinity is difficult to you, we can just change it into 0, x approaches 0. If it's positive infinity, then x approaches 0 from the right. If it's negative infinity, then x approaches 0 from the left. And then we take the regular function and we input in 1 over x instead of x. Okay? And we're going to apply it right now for example 10. So example 10 says, for the function f of x equals x times sine of 1 over x, use the graph of y equals f of 1 over x to find the limit as x approaches infinity and x approaches negative infinity of f of x. So first, it says use the graph. Does that mean I have to graph it out? No, okay, we don't have to graph it out. So what we want to do is find f of what? F of 1 over x, okay? How do we find that? How do we find that? Yeah, substitute 1 over x every time we see what variable? X. So the first x I see, I'm going to now substitute 1 over x times sine of 1 over x. Can I make that prettier than that? Yeah. So this is going to be 1 over x times, what is sine of 1 divided by 1 over x? That's going to be x. Would you agree? That's as simple as I can go. But some of you will recognize this better. Is that equivalent? Yes. Okay. Now the instruction says find the limits of f of x as x approaches both positive and negative infinity. So is that the regular function or f of 1 over x function? This is a regular. That's f of x, right? So we have to be able to read it and know what it's looking for. So it's a regular function. So let's find it. Limits as x approaches positive infinity. Your regular function is x times sine of 1 over x. Okay, let's think about this. What do you think the answer is? Okay, I have a guess of 0. Any other guesses? Okay. I'm gonna borrow decimals.
No.
Decimals. Okay, so cross that out, cross that out. Your regular function was
F of x sine of 1.
so x times sine, so I need functions. And I need sine, and I need 1 divided by x.
Yes.
All right. So let's, that's 1 divided by x. Sorry, delete. Oh. See, I know. My computer is not very nice. Okay, 1 over x. There you go. And pinch that in. I'm going to have to change my window because I don't want it that. Okay, so let's go from what? Y negative 10 to positive 10. Whoa. Look at this. As x approaches something super big, 3,000 or negative 2,000, what's the y value getting? 1, right? Not so much if I'm, can you guys see in the middle, it's really not 1. Can you guys see that? Okay. But as I go super, super large to the right, so when we see that, okay, would you agree I can use my new theorem that's stated on number 2 above? Number 2 above says, the limit as x approaches positive infinity, which is identical to the limit as x approaches 0 from what direction? From the right. Not f of x, though, of what? Yeah, f of 1 over x. Did we find that function already? Yeah, we found it right here. So now that's going to be sine of x divided by x. Now, do we know exactly what that height is? It is a special one. What's the final answer? 1. And does that match Desmos? Yes. Okay. So limit at x approaches negative infinity of your regular function, x times sine of 1 over x, based on our new theorem. What do we write? What is this equivalent to? Yeah, exactly, because the new theorem says I can use x approaches 0 from the left side of f of 1 over x, which we found. And this one, we know how to find the answer. Would you guys agree? Okay, so that's an egg roll. I'm going to